Okay, so first of all, what is a limit? A limit, when we talk about limit, we're talking about the y value. The y value, and this is on the note packet that Val passed out at the very top. So you're using those notes that she passed out. That's what we're using for the next couple of days. Okay. So the limit is the y value the function approaches as x approaches a given value. So the first thing we're going to talk about is finding the limit when we have an equation. Okay. So if this is my function and I want to know the limit as x approaches -4, all you're going to do is substitute in -4. So go ahead and substitute -4 because that's going to tell you what the y value is approaching at -4. So let's do that. So we have 2 plus 8 over, and now inside we're going to put our -4. So when we do that, we get -8 plus 8 over -13, which is 0 divided by -13. Can you take 0 and divide it by a number? Is that possible? What is 0 divided by -13? Is it 0 or is it undefined? It's 0. So your limit for number 1, as x approaches -4, this function is approaching 0. So we'll say it equals 0. All right, let's go ahead and look at the second one. I'll try to write a little smaller. So now we have our function. This is our function right here. And what is x approaching? 2. Good. This is how. Now, this arrow, when you say this in like, this symbol means approaches. So go ahead and substitute a 2 in. So we have something squared plus 3 over something squared minus 6 plus 8, and we're going to put in a 2. So take a second, simplify that down to see what you get. So that gives us 4 plus 3 divided by 4 minus 12 plus 8. So I think that's 7 over 0. Is that 7 over 0? Okay. Can you divide a number by 0? No. So this means that at this point, we have a discontinuity. The discontinuities we talked about in the last chapter, we don't know. We would have to graph it to see what discontinuity exists, if it's removable, if it's a jump, or if it's an infinite. But there is some type of discontinuity happening at 2, so the limit does not exist. So you would say D and E. And again, D and E represents does not exist. And it does not exist because there is a discontinuity at that point. So some type of discontinuity is happening on that graph when x is 2. So that's what that means when you have a 0 in your denominator. All right, let's go ahead, try to do number 3 by yourself. You have your function here and here. And what number are you substituting in your function? -1. Go ahead and do it. So I have a positive 1 minus 1 minus 2 all over a 1 minus 6. So that would be negative 2 over negative 5, or 2/5. Who got 2/5? I'm not using a calculator, so make sure my math is right this morning. So in this example, the y value is approaching 2/5, so it would equal 2 over 5. Yes? Yes, 2 negatives become positive, so yes. So in this last one, number 4, now this one you have to, because it says approaching infinity, so what this is asking you for is the end behavior, which we'll talk about more. But when we talk about end behavior, so when you see an infinity, not a number, that's asking you for the end behavior, which is exactly how it sounds. Like, what is the graph doing on the end? So in order to do that, you have to know a couple of things about the graph, and we'll talk about that more. But if you look at your pink paper, well, no, whatever, I can't remember what color it was, the paper that we did where it was all the different graphs. If you look at that, go ahead and pull that out real quick. Yeah, it was pink. And this is x cubed. So on that function, find your cubic function and tell me, so this is in behavior, because it says positive infinity, this is asking you for the right arrow. So what is the right arrow doing on that graph? Is the arrow on the right going up, or is it going down? Up. So that means that the limit is positive infinity because it's going up. I don't have enough space to write that at the end, but it equals infinity is your answer. So I'm going to go ahead and sketch that graph, what it looks like. That graph looks like this, something like this. And this arrow is going up. Now, if this says as x approaches negative infinity, well, that means the left arrow. And that would be, the answer would be negative infinity. But we'll talk about end behavior a little bit more tomorrow. All right, so now let's look at, so that's how you find the limit if you have an equation. You just substitute it in. And as long as you don't end with a 0 in your denominator, then you have a limit. All right, so now let's look at a graph. So these are a little bit more tricky. So first of all, this just says, this first example, this does not say limit, right? This just says g of 2. So in other words, what is the y value when x equals 2? That's what this is asking you for, your y value when x is 2. So you just look at the graph. Let's find x is 2. And let me go ahead and renumber it because I know these graphs are hard to find, but this is 1, 2, 3, 4, 5, 6. Okay, so that's just your x-axis. I just renumbered it so it's a little bit clearer. So at x equals 2, first of all, what kind of discontinuity exists right here? This is a jump. Does everyone see that? So we're going along, we get to 2, and then we jump to get to a new function. We start off with a linear, then we jump to go to a constant. Now, which one of these points am I going to use, though? All right, so what is, let's see, what is this y? So the y-axis is counting by halves. But let's go ahead and number these also. So this one is 1, this is 2, this is 3, and this is 4. So it's a little bit easier to understand that axis because it's kind of small too. All right, so what is my answer going to be? Is it going to be 1 or is it 3? Which one am I going to use for A? The 3. So the answer to part A is 3. Now, one thing I want you to write too off to the side is that now this is really important, the only discontinuity that says discontinuity that has a limit is a removable. That's really, really, really important. If you have a jump or an infinite, the limit does not exist when we're talking about a limit. Now, part A was not asking for a limit. So that's really, really, that kind of helps you with these limits, because if you're looking at a graph and you see a jump or an infinite at a certain x value, then you automatically know the answer is D and E. It's only a removable that would actually have a limit. All right, the other thing to keep in mind when we're talking about limits, so if it says the limit as x approaches a number when it has a little minus sign afterward, can you write this here? We need to do a little bit background before we do these graphs. If you see a little minus sign afterwards, that means the left side. That's what that means when you see that little minus sign. Because notice how for part B, do you see how it has a little minus sign afterward? That's asking you for the left side. What's happening on the left side? Conversely, if you see a plus sign afterwards, that's asking you for the right. Okay, so now that we have that, let's look at this one a little closer. So notice how for part B, do you see this little minus sign right here? So notice that at 2 we have a jump. So I'm going to put a little line here. At 2 we have a jump. The left side of 2 is right here. So if it's asking you for the left, it's asking you if you were to draw in this invisible vertical line, where does the graph touch the line on the left? So on the left side, it touches this line at 1. So the limit as x approaches 2 from the left. So again, this means x approaches 2 from left. So what do you think the limit would be? Where is it touching the line? 1. So the answer would be 1. Part C has a little plus sign, so that means from the right. So from the right, here we are. So we have, at the 2, because there is a jump, there's 2 different y values. So part B is asking you for the left side, which is 1. Part C is asking for the right side, which would be what? 3. Now at 2, because it's a jump, the limit does not exist. So the only time you have a limit at a number is if the left side and the right side are in agreement. So if we're not in agreement, then we can't reach a conclusion of what 2 is. the limit at 2. All right, let's look at number 3. So again, number 3, I'm going to go ahead and erase this. Okay, so now we're talking about 3. So again, at 3, this is not asking us for a limit. This is saying what is the y value when x is 3. So which one of these am I going to use? What's the y value? So there is a closed circle here. This one is open, so we don't use that one. It's closed here, so that would be 2. So the answer is 2. Now we're going to talk about the limit. So what side am I talking about for this one? Left. See, for F, do you see how there's a little minus sign after there? So that means from the left. So from the left, which one of these am I going to use? So it's either 3 or 2. So it doesn't matter which one is open or closed, okay, because it's what side is what on the left side of 3. So what is the answer going to be? 3. Now this is saying from the right for part G. On the right side, the limit would be 2. Now it did not ask me for the limit at 3, but if it did, it would be does not exist, because the left and the right are different. All right, what about 4? At 4, right here, what is the y value right here? 3, so the answer is 3. Now when we talk about the limit at 4, as long as, so you see how I drew that dashed line at 4? As long as the left and the right are coming together at the same place, we have a limit. And the limit is that place. Okay? This is the first time we did not have a discontinuity. So the limit at 4 is also 3, because the left and the right are coming together at the same place. All right, let's look at another graph. Any questions about that one? Just looking at graphs, trying to figure out the limit. All right, so let's look at this one. We got a lot of stuff going on here. And let's start with the first one. So this says as x approaches 4. So as x approaches 4, that would be right here. So remember what I said, as long as the left side and the right side are meeting up, we have a limit. So what is that y value going to be? 2. That would be the limit at 4. All right, this says 0 from the left. Oh, I'm sorry, I'm going the wrong way. I'm supposed to go across this time. All right, so 3 from the left. So where is 3? I'm gonna draw my dashed line. Definitely have a discontinuity happening here. Got an infinite. So at the 3, what's happening on the left side of this line? What's happening to the graph? Notice that it's going down, right? Does everyone see that? So because the arrow is going down, the y value is approaching negative infinity. That's what's happening on the left side of the wall. On the right side of the wall, which is right here, we have a constant function. What is the y value at this point right here? What is y equal? 2. So the limit on the right is 2. Now remember what I said, that for you to have a limit, that means the left side and the right side have to agree. The left side, we got negative infinity. The right side, we got a positive 2. So that means what? What's my limit going to be right here? Does not exist. All right, 0 from the left and 0 from the right, and then 0. So right here, let me go ahead and erase that wall. Move our wall over now to 0. Okay. So on the left side, this says 0 from the left. That little minus sign means from the left. So on the left side of the wall, what's happening to the arrow? What is it doing? Going down. Does everyone see that? It's going down, so that means that it would be negative infinity. What's happening on the right side of the wall? Directly to the right, what's happening to the arrow? On up. So what's my limit on the right? Positive infinity. Now, are these the same? Are they doing the same thing on the left and the right? So what's the limit going to be at 0? D and E. Now, this says positive infinity. So what this is asking you is the far right arrow. The far right arrow, which would be this arrow. This is the far right arrow. What is happening to the y value? It looks like it's going horizontal. It's constant. So what would be the limit? It's constant at what y value? 4. So the limit would be 4. Now this one is saying the far left arrow. Let me do that in a different color, actually. So that would be this arrow right here. What's that arrow doing? Is it going? It's only 3 options. Either it's going up, down, or straight, constant. So what does that arrow look like it's doing? Going up. So what would be the limit? Positive or negative infinity? Positive infinity. Good job. Now this says -2. See how that minus sign is in front? That doesn't mean 2 from the left. That means look at x equals -2 and tell me the limit. So let me erase these walls that I have here. And then I'm going to go to -2 and I'm going to draw a line. Now, on the left side, so here's the line I just drew on the graph. The left and right side, are they coming together? Yes. And that's why I said the only discontinuity that has a limit is a what? A removable. And we have a removable right here. This is a removable discontinuity. However, the left and right side, they are coming together at the same place. So the limit is 3. A removable is the only discontinuity that does have a limit. All right, now let's look at x equals 5. I'm going to have you do that one. See if you can figure out the answer to x equals 5. Or as x approaches 5, I should say. What would you guess for the limit as x approaches 5? It doesn't say 5 from the left or 5 from the right. It's saying at positive 5. So what would you say the limit is?
4.
Am I looking at the right graph? Hold on. At 5? D and E. Why is it D and E? I just knew we were going to be like unanimous. I was like, they gonna get this answer right. I was ready. And then I was disappointed. It's okay though. What kind of discontinuity? Okay, so again, looking at this wall. It's only our first day. Look at the wall. Val, look at the wall. Everybody look at the wall. Is the left and the right side coming together at the same spot on the wall? Are they touching the wall at the same place? No. So it does not exist. This is a jump. A jump does not have a limit. All right, look at -5. See if you can get that one. Okay, so let me draw my little wall in. Here's my wall. I don't see a discontinuity happening there, so we have a limit. Anybody want to take a guess? What would you say the limit was? Well, it's kind of close. Well, I would accept -1. I would accept any number between 0 and -1. Because it's somewhere between 0 and -1. I would probably say -1/2. All right, go ahead and see if you can answer those 3 questions at the bottom. We'll end there. What kind of discontinuities? Is it continuous? Yes or no? If it's not continuous, name that discontinuity. Is it a jump? Is it a removable? Or is it infinite? So take a minute. Go ahead and answer 13, 14, and 15. Okay, so at 0, what kind of discontinuity do you have at 0? Infinite. So at 0, right here, notice how the left side is approaching infinity and the right side is approaching. So anytime you're approaching infinity, you have an infinite. If it's positive or negative infinity, that doesn't matter. All right, at -2, what do you call that? Removable. That's the only one that has a limit. A removable has a limit. And then the last one is at 5. So that would be right here. What's happening right there? It's a jump. Okay, we are going to practice more. When you do homework 12, I recommend you do it in pencil. Okay, so you can erase. And we will pick up here tomorrow.